Okay, so hello everyone, this is Akshay, and let us continue with today's problem of the day. Today's question name is maximum people visible in the line, and today's day is 623. And let us resume with today's question. तो तुरंत से नोटपैड पे चलते हैं एंड विल सी व्हाट टुडेस क्वेश्चन इज. आज का जो क्वेश्चन है यार, ये दिस इज़ वेरी सिमिलर टू द क्वेश्चन वी हैव डन yesterday and day before yesterday as well. Some of sub array ranges and stock span problem. ज़रूर से आप ये प्रॉब्लम करना, ये तो ज़रूर से ही करना. बहुत 5 से 6 क्वेश्चन कवर हो जाते हैं ये क्वेश्चन करने में, राइट? तो ठीक है. आज का क्वेश्चन मैं देख पा रहा हूँ, इट इज़ मैक्सिमम पीपल विजिबल इन अ लाइन. सो आई एम गोना सॉल्व दिस वन टुडे and mark day 623 as completed, and we'll move ahead. I'm going to move ahead. So we are given an array I, where array of I represents the height of the ith person standing in a line. A person I can see another person j if these conditions satisfy. ठीक है, अगर आप if you have read this condition, तो ये condition basically ये बोल रहा है, यहाँ पे एक jth person है और यहाँ पे एक ith person है. ठीक है, height of I is greater than height of j, right? तभी ये j को देख पा रहा है. ऑब्वियसली बात है, अगर यहाँ पे कोई एक k पर्सन खड़ा होता, लेट्स से, राइट, जिसकी हाइट आई से बड़ी होती. देखो, देयर इज नो के पर्सन स्टैंडिंग बिटवीन सच दैट हाइट ऑफ के इज हाइट ऑफ आई, बट लेट्स से इफ देयर वाज अ के पर्सन व्हिच हैज द हाइट ग्रेटर देन के, देन डेफिनेटली दिस ith पर्सन वुड बी सीइंग अ वॉल ऑफ द के ऑफ हाइट ऑफ के पर्सन, एंड ये जे को वो नहीं देख पाता, राइट? सो दैट्स बिन रिटन हियर, राइट? द सेकंड says the second line says that each person can see in both directions, front and back. So this I can see all the possible j's in the left direction, and if there are j1 j2 present like this, then the ith person can see these two persons as well, right? So that means it can see in both right and left directions. The array given is 6 2 5 4 5 1 and 6, right? Let us do a quick try run, and then we'll think of how can I solve this one. So 6 2 5 4 5 1 and 6, right? So one thing more is written here, I can see, is that your task is to find the maximum number of people that any person can see, including themselves. Okay, so we need to include the same person in the count as well. So for this person, this, or let's say the person 1, person 2, person 3, 4 5 and 6. So the person, and so person 7, person 1 can see himself, right? And so the count first of all is 1, and all the person which are till 2 to 6 are the person which has a height lesser than the person 1. So definitely the person 1 can see these persons, that is range from 2 to 6, but it cannot see the person 7 because it has the same height, right? That's what the question says. It clearly says that height of I is greater than height of j. It does not says the inequality is there, right? Equality is not there. It does not says less than equals to. So we'll just take the person who has lesser height. So these 5% plus including himself, it would be 6, and that the expected output is also saying 6, right? Similarly for this 2, if you look in the right hand side, then definitely there would be a wall here, and there would be a wall in the left hand side. So only one person, that is 2, the person 2 can see himself only. For this 5, there is a wall here, and not a wall, basically a height which is equal to its height, equal to the person 3 height, and which does not satisfy the condition. So the person 3 can see person 4 and person 2, right? So the number of person 3 can see is himself and 2 other person, that is 3. Similarly for 4, I can see there are 2 persons standing in left and right, both has the height greater than the person 4. So the person 4 can only see to himself, that is the count is 1. Similarly for 5, it can see person 6, person 4 and himself, so the count is 3. Person 6 can only see himself because both the persons in the left and right has the height greater than the person 6, so the count is 1. And for person 7, it is 6, so he can see himself, and all this person that is ranging from 2 to 6, so total number of person the person 7 can see is 6. So the maximum number of people that any person can see is the maximum of this particular answer or array, or let's say the range. So 6 would be the answer, right? So it's a brute force technique. What would be the brute force? That for each and every I, let's say we are starting at this position, for each and every I traverse, or I look in the right hand side direction. For the people who has the height lesser than this ith person, I'll do a count plus plus, and in the else case I'll break. Similarly, Once the right direction is completed, I'll look into the left direction and follow the same condition. That is, the person in the left hand side direction has the height lesser than this height person, then count plus s break. After the two nested for loop, we're just gonna have a the maximum. We just track the maximum of that count, right? So what I'm saying is that if we start from I equals to 0, I less than n, I plus plus, right? Then we have two for loop, that is going from j equals to I plus 1, j less than n, and j plus plus, right? The condition would be that if array of I is greater than array of j, then we do a count plus plus, right? And initially for each and every person the count would be 1 because the ith person can see it to himself. And let us declare an answer as well, which is 1. The minimum answer for any person would be 1 because that person can see themselves, right? And again there would be a parallel for loop going from j equals to I minus 1, j greater than equals to 0, and j minus minus, right? That is, this is the right direction and this is the left direction. Again the same condition, that is, if array of I is greater than array of j, in that case count plus plus, else break. Here would be one more condition, that is else break. This for loop ends here, the parallel for loops ends here, and this for loop will have an answer which will just say math.max answer comma count, and that's it. But what would be the time and space for this one? Time would be O of n square, right? This would take O of n, and this would take O of n, this would take O of n at max. So it would be n into 2n, right? Ignoring the constants, n square. And space complexity would be O of 1. But if you see the constraint, it is 10 power 4, right? And we're using n square, so definitely 10 power 4 square is equals to 10 power 8, right? Almost close to 10 power 8 operations we need to, and definitely we'll hit a TLE because for a successful summation the ideal iteration should be less than equals to 10 power 8, right? And if you don't understand this, then there's a video here that is trick the TLE by Akshay. If you search this on YouTube, and you'll get more insights on that. Okay, so let's pause this one and we'll see the brute force technique now. So here goes our brute force technique as we discussed, and let us hit the submit button. So we hit the TLE now. What would be the optimized one? The optimized one हमने बहुत बार कर रखा है इसका, and if I have solved the yesterday's question as well, and some standard question from stack, that is the previous grader, previous smaller, next smaller, and next grader. Using that it would be done. But the idea here is that how can we visualize that one? So let's say we have this thing 1 2 3 4 5 6 and 7. There were 7 persons, and the height were 6 2 5 4 5 1 and 6, right? I'm talking about this index. Let's say I'm standing at this index I for this person 3 having the height as 5, right? Having the height as 5. Okay, so what I am seeing that if I am able to find the next greater element for this index I in the right hand side direction, basically the next greater, and next greater means that we need to find in the right hand in the right direction. Similarly, previous greater would mean that we find the greater element in the left direction, right? So in this case we just want the next greater, next equal or greater element, in this case equal or greater, and previous greater or equal, right? Both of the case. So assuming that we had this logic written in past, so the index would come around here, this k, right? And for this ith index, the previous greater index would be coming around here, j, and the answer would be nothing but k minus I, right, plus I minus j. This would give me the person count from the right hand side direction including himself, right? This I minus j would be the give me the person count from the left hand direction including himself. So I included the ith index twice, right? So in this whole answer I will just do a -1 and I will return it, right? So coming back, that how do we code the solution of previous greater and next greater. So here is a complete question we solved yesterday. You can watch that video. That is this one. Where is that? This one, sum of sub-array ranges, and I have explicit video recorded as well. Day 621 covers the previous greater, and day 87 covers the next greater element. So what I'm gonna do is I'm gonna copy the same code which I did yesterday. That is the next greater and the previous greater thing. So I'm gonna copy this code. I'm gonna erase this particular code. Right, I'm gonna take the same things again, and I'm gonna remove this line. I don't need it. No, I don't need this one. Now this question, greater right max, right? So we do not need to check for the equal sign, right? So we're gonna remove this equality from here, and that's it, I guess. I'm gonna use this line again, and I'm gonna remove this line. I'm gonna remove left min, right min. I need left max and R max, right? So answer equals to math dot max answer, comma, left max plus right max minus 1, as we discussed, and initialize this as that goes our solution now. So if you have solved the question in the past, so I do not code it again, I just use my previous solution, and you should do the same. So case 1 is passed. Let's hit the submit button. What would be the time and space for this one? So O of n for this for loop and O of n for this for loop. So O of 2n, ignoring the constant, to be O of n, and O of 1 as space. No, not O of 1, because since we're using a stack, so this previous greater element would take O of n as time and O of n as space. Similarly, this next greater would take O of n as time and O of n as space. So O of 2n as space complexity, ignoring the constant, would be O of n. And that's it for this one. Till then, keep learning, keep by, and take care. Do feel free to check out our YouTube channel, which has a bunch of other playlists. That is 180 top interview questions, which has helped me to come this far, and much more coming in the journey. Now, the another section which I explore basically travel life and beyond the code, and multiple places are there. You can feel free to check it out. Join our Discord channel where I post the regular updates, and we can meet again in the next video. Till then, keep learning, keep by, and take care.